Today we're still going to do chapter 7 and we are going to focus on lenses. These are the answers for today's questions. Questions 1. An object and a screen separated by a distance of 72 cm. At what locations between the object and the screen should a convex lens of focal length 10 cm be placed to produce a clear image on the screen? According to the questions, you are given the values of the length which is equal to 10 cm. But that is not enough to determine the positions of the lens. In order to determine the positions of the lens, you need one more information, which is either u and v. But obviously, we don't have it in this question. So how are we going to solve this question? Let's sketch a diagram and see is there any ways to find the values of u and v. So this is a diagram. According to the questions, the distance between O and I is 72 cm, and lens is located in between them. But you don't have the positions of the lens. So let's just label it as U and V. Now, if you look at this diagram, U plus V is equals to 72 cm. So rearrange the equations, we now have U equals to 72 minus V. And that would be our equations 1. But still, we cannot solve the equations by just using this one equations because you have two unknown. So let's form one more equations by using the focal length. So 1 over f equals to 1 over v plus 1 over u. Substitute the values into the equations. You now have the second equations with two unknowns, which is u and v. Now that you have two equations with two unknown, let's solve the equations by substituting equations 1 into equations 2. So substitute into the equations 2 and you will obtain V is equals to 60 cm or V is equals to 12 cm. You get two values of V right now. Let's check whether the two values obtained in the previous slide is correct or not by substituting the values into equations 1. So sub V equals to 12 cm into equations 1, you will get U equals to 60 cm. And if you sub V equals to 60 cm into equations 1, you will then obtain U equals to 12 cm. So which means the lens can be placed at 12 cm or 60 cm from either the lens or the screen. Questions 2. A diverging lens forms an image 1/3 of the size of an object placed 24 cm from the lens. Find the focal length of the lens. To find the focal length of the lens, you need both U and V. But now you don't have enough information. So what are we going to do? Let's try to analyze the questions. First of all, you are given a diverging lens. When you are given diverging lens, it means the image is always upright. And thus, M is a positive value. Now, why is it important to know whether M is positive or negative? Because you are given the magnifications of the image. According to the questions, now this lens, it forms an image 1/3 of the size of an object. So based on the terms diverging lens, we know M is positive, and therefore we have M equals to positive 1/3. Now that you have M equals to 1/3, let's try to substitute it into the equations of linear magnifications. So given linear magnifications, M is equals to negative V over U. Substitute M equals to 1/3 into the equations and U equals to 24 into the equations. You will then get V equals to negative X cm. Now that you have U and V, let's apply the equation for length. So 1/f equals to 1/u plus 1/v. Substitute the values into the equations and you will get F equals to negative 12 cm. Well, this negative, it tells you this lens is a diverging lens. So yes, we got the right value. Questions 3. A planar convex lens has a radius of curvature of 10 cm and its refractive index is 1.5. A. Calculate the focal length of the lens. Is it a converging or diverging lens? B. If the same lens is placed in liquid of refractive index 2.0, what is its new focal length? Does it act as a converging or diverging lens right now? So how to determine the focal length of the lens? You are given the radius of curvature and also the refractive index of the lens. So let's apply the equation for focal length. F equals to n material over n medium minus 1 times 1 over R1 minus 1 over R2. Now in this case, you are given a planar convex lens. There are two possibilities to arrange the lens. So the first one is the flat surface is facing the left-hand side, and the second possibility is the flat surface is facing the right-hand side. Does it matter which one to use in our questions? Well, it doesn't matter. I will show it to you why. So now let's analyze them one by one. So for case 1, let's assume the object is on the left-hand side. When your object is on the left-hand side, then the flat surface will be acting as a R1. And the value is infinity because it is a flat surface. And the second surface would be R2. And now this curved surface is a negative value because it is concave towards the object. So that is the R1 and R2 in case 1. How about case 2? Now case 2, again, let's assume the object is on the left-hand side. But now the curved surface would be acting as R1. And now this curved surface is convex towards the object. Therefore, this R1 is now acting as a positive value. So R1 is equals to positive 10 cm. And the flat surface would now becomes our R2, and it is still equals to infinity because it is a flat surface. It is a straight line. Now that we have R1 and R2 for both cases, let us substitute it into the equations. So case 1, if you substitute R1 as infinity and R2 as negative 10, the focal length would be equals to positive 20 cm. Whereas for case 2, if you substitute R1 as positive 10 and R2 as an infinity, you will still get F equals to positive 20 cm. Which shows you it doesn't matter how you arrange the planar convex. As long as you got the R1 and R2 correct, then you will still get the same answer. And how do we know whether it is converging or diverging lens? Well, since F is a positive value, thus the ones that we have now is a converging lens. Questions B basically same as questions A. The only difference now is you immerse this planar convex lens into a liquid with refractive index 2.0. So how to find the focal length? Again, let's apply the equations for focal length. So F equals to n material over n medium minus 1 times 1 over R1 minus 1 over R2. So let's just take the diagram from case 1. Where R1 is infinity and R2 is equals to negative 10 cm. So substitute the values into the equations, you will get F equals to negative 40 cm. So the things that you have to take note here is that your N medium is no longer equals to 1, it is now equals to 2.0. So how to tell whether it is a converging or diverging lens? You look at the sign conventions for F. So since F is a negative value now, thus it is a diverging lens. So that's all for today. I will see you all again tomorrow.